This episode of Hoochos is brought to you by Skillshare. Welcome back to Hoochos. Today on Hoochos, we're going to be building this. This is the Wick Wedge Hydroponic System, a wicking rain gutter grow system based hydroponic system that works using grow bags and wicks with a wedge that fits into the system that we can use to eliminate major expenses in the growing of vegetables hydroponically at home. This is the one that I've been keeping a secret for so long. It's been really hard to hold my tongue, and I've designed a brand new 3D print just for you guys. So first things first, let's clear out the space for this new system. So the reason I'm cutting down these plants and not moving them to another area is that they've not been properly managed. As you can see with the eggplant, there's just no fruiting happening, and that's purely because of a lack of pollination. And the capsicums were improperly managed as well. So I figured just start all over again, reset the system, and see if I can do better next time. I've been really impressed with the hooch buckets, and I don't think that media size is too small anymore. I think you can get a really decent sized plant out of those bucket sizes. So I won't be needing this support system purely because I want to get it as low to the ground as possible so I have as much grow height that I can get from this system. So I'm going to remove them all. Lift with the legs. All right, now that I've got a nice open area to work with, I'm going to set up two rain gutter grow systems which both have 3D printable end caps on them. You can find these 3D printable end caps on my Patreon in the same place that you can find this 3D printable Wick Wedge Hydroponic System. I've also got a video on how to set these up with or without the 3D printable end caps, and you can find that here. So I'd previously set these rain gutter grow systems up for another purpose, and the whole spacing or the whole density isn't as much as I'd like. I'd like 3 wicks per bag. What I'm going to do is I'm going to go along and add an extra hole into this spacing. And I'm pretty sure this is 30 or 35 centimeters or 350 to 300 mils apart. It'll just depend on the size bag of cocoa that you're using. So just space it appropriately. So what I'm going to do is I'm going to go along and add in an extra wick wedge between each of these holes. The hole saw that I'm using is 63 millimeter or a 2-15/32, 2/15 of a 32, I don't know. Here's the hole size. That will allow the wick wedge to slot in perfectly. So I'm gonna go along and put in these holes. Yep, so these holes are 35 centimeters or 350 mil apart. I'm going to do 2 experiments within this system. I'm going to leave the spacing of 350 millimeters apart on this one, and we're going to have 1, 2, 3, we're going to have 4 bags. With the smaller spacing, I can fit in more bags. So I can have 1, 2, 3, 4, I can have 5 bags. And I'm going to see how 2 wicks goes in one bag compared to 3 wicks in one bag, purely to sate my own interest, but also to just see whether or not you will need to print an extra one for the middle if it is successful. This will just reduce the amount of filament that you'll need to go through to successfully wick into one bag of cocoa. Now you can still achieve the same density, it's just that I've already set this up. So if I wanted to achieve the same density, I'd shorten the distance between the 2 wicks and then just maximize the amount of bags that I can fit onto this channel by just measuring the bags that I've got and laying out the maximum amount of bags. So your bag size might change, and that will change the distance apart that you have your wicks. Now, because this system needs to be level to function, I'm going to go along and level the system. Okay, now I'm going to cut timber so that it supports on each side. I'm actually just going to set up one at the moment. Then when I get a chance to go to the hardware store, I'll buy another couple of these sticks and put them on that side. To start with, I'm going to make sure that it's truly level. I'm going to fill it up with hydroponic nutrient. So to do this, I'm going to add on my float and I'm going to let it fill up for my res, which is full of hydroponic nutrient. Now that's pH and EC balanced hydroponic nutrient, around about a pH between 6 and 6.45, and the EC is 2.4. And I'm using my hydroponic nutrient, which is the Campbell's Diamond Specialty, as well as that I'm using the Campbell's calcium nitrate. So to set up the ends, all I'm going to do is I'm going to add in our float valve. Just going to pop that in to the end like this. The way these systems works is the float will top up this pipe running underneath the system, and as the plants use up the hydroponic nutrients through transpiration, it's topped up by this float valve and topped up with full strength hydroponic nutrient. So I'll just screw that into place and I'll try and set it as best as I can to the height that I want it. So I'm going to add in the screw on the end, and then I'm going to add in some plumber's tape. And then I'm going to add in my 13mm to BSB barbed fitting. This adapts our 13mm hose to our float valve. Now I'm going to turn on the tap to my res. It's turned on. So we just need to adjust this. That looks about right there. So when it drops, it fills. Now I'll just turn the tap off at the other end so it doesn't drain. And this tap is for emptying the system. So I'll just turn that off and we'll wait for it to fill and see if we've got a true level. Okay, so something that's definitely high on my list of things not to do while setting these up is don't go away on lunch and let them fill up and find out that you've not turned off one of the taps, because this is what will happen. I've just been draining the res that whole time. Luckily, it's only a 13mm tap and it's not filling extremely fast, but I did drain about 100 litres. So don't do that. What I have got though is a fairly nice level on both of the systems. I've sloped them a bit towards the taps so that when I turn the taps on, it will drain them completely. I'm pretty happy with the levels. So we're now going to set up our wick wedges. But first I want to talk to you about the sponsor of today's video, Skillshare. Skillshare is an online learning community with thousands of inspiring classes for creators just like you and I. Skillshare can enable you to learn new skills, deep dive into existing passions, and get lost in your own creativity. I've personally found the YouTube Success class with MKBHD extremely insightful. In this class, Marquez gives insights on how to structure YouTube videos that I've found extremely useful in the running of my YouTube channel. But you may have other interests. On this channel, we discuss 3D printing, 3D modeling, gardening, and a variety of other topics that Skillshare has classes on. If any of this sounds appealing, consider joining by clicking the link in the description below. The first 1,000 people to use this link will get a free 1-month trial that Skillshare is offering to the viewers of this channel. I don't know if you've noticed, but throughout this whole video, all these plants have been slowly wilting, and that's because the float valve in that system was clogged with algae, and I'm actually changing all of the floats. Here it is. But you can see the algae buildup in this style of float is way worse than this style of float. Now, it's really hard to tell when you're buying which float you're going to get, but this is the style you want. This is the hammer style. So this part sits internally in this float. I always pull these out. All I do is make them clog faster. It's much easier with pliers. So pull that out, and you can see on the inside, I've got a much larger hole for the nutrients to come out of, and it's hammered closed like that. With this other rounded style, where I can't even really show you how it works because it's hidden behind this mechanism. But if we have a look down the end of it, this is the worst case scenario. It's just completely blocked with algae. At the end, I can't even really show you because it's so small. That is the difference in the hole size. So that's the hole that the hammer's blocking. You can see the difference. It's huge. That's the hammer, and it's got a little bit of silicone on the end of it. That just needs to be bigger. I don't know why they haven't made it bigger. Another problem with these ones is that because of the part that connects the hose to the back only comes up that far, you get algal growth in that. So if you chop that off and run a drill down, I reckon we can open these up a little bit more. I think we can fix this. You're just gonna have to play around with drilling out these holes. It's actually been a couple of days since I set this up. You can tell that all of the capsicums have regained their turgidity and they're back to looking healthy. This is the beauty of working whilst trying to manage a YouTube channel. I haven't had the time to put them in. So now we're gonna set up the wick wedges. Now to do this, there's two options. We've got purpose-bought wicking material and cotton sash. So the cotton should act as a wicking material, although I expect the self-watering wicking material to work better and also last longer. So I'm going to use both, and I'm going to let you know if there's any detriment to using the cotton or benefit to using the actual purpose wicking material. Now this is our wick wedge. Now I've designed this specifically to fit in our rain gutter grow system and support the wedge from the base of the channel, so that once we push our bagged media over the top of this wedge, it's supported from below as it penetrates into the bagged media. Okay, so just a quick design discussion. Just ignore that. That's an upcoming design. It's actually available on my pre-release tier if you're interested. But anyway, so the way that I've designed this 3D print is that it should be printed with a relatively high infill density purely because it's structural. So as you're placing the bag over the top of it, it's gonna incur some force onto the 3D print. So you really want to have a decent amount of infill. I'd recommend anywhere from 40 upwards. I think I printed these at 50% infill. It's designed so that the water can penetrate through the base into underneath of the wick wedge, and it allows the wicks to draw water up through these 4 holes through capillary action and translate that water to the cocoa within the bags. Now, I've also put a lip on the base where the bag touches the top of the cylinder at the base of the wick wedge, so that it will hopefully seal and we won't get too many leaks. The wicks will run from the base up through the top and then down and back down into the base. At the top, I've created this sort of serrated wedge shape so that it breaks the bag as you force it over the top, and that wedge cuts straight through the cocoa perfectly. It prints in one piece, so as you can see, if we do a cut through like that, it's all domed. Everything will print perfectly without supports. So a single wick wedge is going to take 4 hours and 17 minutes to print at 50% infill density, and it's going to take 108 grams of filament. So if you're paying $20 per kilogram for filament, this is going to cost about $2 per wick wedge that you print. Print in one piece, a relatively high infill density, no adhesion, and you'll have a good time. So to set up this wedge, we're going to take our wicking material. I'm going to cut it in a length so that we make sure that both ends of the wick are down in the nutrient solution, like that. You'll need 4 for every wedge, and then we can just push that straight down into the base of our wick wedge, feed it through the top hole, like that, and then back down the other side, like so. And we'll do this for all 4 sections of all of our wick wedges. You can see I've been busy printing. Okay, so I've wicked up 6 of the wick wedges, and I'm now gonna place them out in the channels. I'm gonna do a 24-hour test with 2 grow bags, and we're gonna see if the wicks supply hydroponic nutrient to the grow bag without me watering it in. And then tomorrow, if that's worked, I'll just put all the grow bags out without watering them in. So I'm gonna place out the wicks and we'll put it on our grow bags. We're now gonna add on our bag. This is a premium grade of hydroponic cocoa. So it's been amended with calcium and magnesium to replace the potassium that usually locks out the nutrients in cocoa. Make sure you're using a hydroponic grade bagged cocoa for this and you'll have a good time. This is the first time I've done this. Okay, so what have I learned already? The bowing in this channel isn't ideal. Essentially, you're going to want to have this supported from below if you're putting pressure on these things when you're throwing that bag down. Ideally, you're going to want this on some supported base. Let's throw a second one on and we'll wait 24 hours, see how they wick. Beautiful. Very cool. So I'm actually going to add in another bag because I got 2 extra wicked up and I want to see how well the 2 wick wedges work at supplying nutrients to the bags. So it's been 48 hours since I set up these bags. And as you can see, there is a leak coming out of one of them. I'll fix that in a second. But now we can actually see if the cocoa has wicked in the water. Now, on the top of these bags, I can actually see condensation, which is a good sign. It means that the water is condensing on the plastic. So we'll cut them open and make sure that our nutrient has wicked up into our cocoa. I'm going to plant 2 plants in each bag and I'm just going to cut an X into the spots where I want the plants to be. So I'll just do that. And have a look at that. That's wet. How good. I'm very happy with that. Now, this bag may not provide enough oxygen, so I may go in and add in some air holes, but I'm gonna leave it as is just to see how the plants go in this state. But have a look at that. I'm really happy with that. That's worked so well. That is wet. Yeah, really wet. Fantastic. Okay, so I'm actually going to remove a bit of this cocoa, set it aside, and then we can plant the plants into our holes. So I've got a selection of plants here today. These are pumpkins, watermelon, lettuce, but I'm actually going to be focusing on planting cucumbers. To do that, I'm just going to take my cucumber plant and we'll just plug it into the hole and we can just fill around it with the cocoa that we've taken out. So like this. We'll do the same again for this hole. Like so. And I'll go along and do that for the rest of the bags. I'm also going to set up all the other wick wedges and grow bags. So as you can see, it's really hot here and I may have killed these seedlings. I actually don't have enough seedlings for this system, the cucumber seedlings. And the reason being is I hurt my back and I've been putting off making it until my back was better. And it is somewhat better now, but I had cucumber seedlings up in the NFT for this purpose and they got too big and I had to move them out of the NFT. So what I'm going to do is I'm going to set up the rest of the system. I'm going to go and purchase some seedlings just as a time-saving measure. And with the rest of these wick wedges, I'm actually using, this is 6mm cotton sash. So this is a cheaper option than the previous wick wedges, which were this Ormeric self-watering wick. So I'll let you know which works better, but that's purpose made and this cotton should do just fine though. I'm actually pretty happy with how wet these back bags are with just 2 wicks. I'm actually going to plant the rest of these bags with only 2 wicks, 1 on each side, and we can compare the 3 versus the 2 with this grow bag size. So it's later in the afternoon. Our seedlings have come back a little bit. I'm not saying there's no damage done there, but I really should have planted those about now. So I'm going to go through and plant all these seedlings that I've purchased from a nursery. They're in soil. I'm not particularly worried because this is not a recirculating system. Any algal bloom will only happen around the base of the plant, and there's no recirculating water, it's just wicking action, so it won't really spread. It's not really a big problem. I'm going to plant straight into the top of these bags, the same as I've done over here. So I am going to try and get as much soil off the root ball of the plant as I can without disturbing the roots too much. See, I'm not going to be able to get much soil off that at all because it's perfectly rooted. So I'll just take the top off, place it in like that. And there it is, all planted and ready to go. So the benefits of this hydroponic system, it's gravity fed from a reservoir, tops up automatically from the float valve, and the design of the wedge means that very little, if any, roots will get down into the bottom gutter. Undoubtedly, they will make their way down there because these are cucurbits and they just seem to cause me trouble all the time. The media is cocoa peat, it's hydroponic grade, it has the perfect amount of oxygenation, moisture holding capacity, as well as cation exchange capacity, which allows it to wick up and hold onto nutrients and release the nutrients to the plants when they need it. I'm hoping that this gives plants the ideal conditions for growing, and the bags should hold the moisture, so there will be next to no evaporation from this system. They'll also keep the light out, I'm hoping, enough to keep algae from growing on the insides of the bags. So we'll leave them for a couple of days and then we'll come back and have a look at how they go. Well, it's been about 5 days since we first planted these bags and they're going really well. As you can see, I still haven't fixed that leak, but I'm really stoked with how they're progressing, and I've been pretty lucky that after that initial day of really intense sun when I planted the end seedlings, we've had relatively mild weather, which has allowed the rest to acclimatize really well, and I wouldn't be worried about them in more harsh days to come. So this design will be available through my Patreon. All of my 3D prints are available through my Patreon, and I'm going to make a specific tier for if you want to use this design in a commercial setting, because I can actually foresee this style of planting being used in a setting where someone has access to a production facility that can bag up their own cheap cocoa and then allowing the workers to pull along a pallet of cocoa and just smack bags down onto a production facility floor and plant in their seedlings in a larger scale environment. Now obviously you'd adapt the gutters to that environment, but I do see this being commercially scalable. As for patenting, if anyone's looking at this going, hey, I can patent that, just consider this prior art. And that's it. That is the Wick Wedge Hydroponic System. I really hope you enjoyed this episode of Hoochos. I was super excited to bring it to you, and I hope you get some really good productivity out of this system if you plan on using it. Happy hydroponicking, and I'll see you next time on Hoochos.